Welcome back to IT Master, your go-to channel for learning modern web development, SVG animation, and creative front-end engineering step by step. In our SVG animation series, we've already learned how to animate paths and shapes. But today, we're moving to the professional level. In this tutorial, we will build a real GUI liquid animation from scratch using SVG Filters, feGaussianBlur, feColorMatrix, and GSAP animation. And everything will be created inside one simple HTML file. Let's start coding. Section 1. Creating the SVG workspace. First, create a new HTML file. Now add a basic SVG container. Now, let's start by creating the foundation of our SVG. Here, we are using the SVG element, which stands for Scalable Vector Graphics. SVG allows us to create graphics using code instead of images. Inside the SVG tag, we added an attribute called ViewBox. The value 00, 600, 300 defines the internal drawing area of the SVG. The first two numbers, 0 and 0, represent the starting position on the X and Y axis. The next two numbers, 600 and 300, define the width and height of the SVG canvas. You can think of this as creating a virtual coordinate system where all shapes and animations will be drawn. Right now, the SVG is empty, but this is our main container. In the next step, we will start adding shapes and visual elements inside it. SVG filters are defined inside the DFS tag. Anything inside DFS works like reusable visual effects. Now add two circles. Now, we are adding two circles inside our SVG canvas. First, we use the circle element, which is used to draw a circle shape in SVG. Let's understand the attributes. The CX attribute defines the horizontal position of the circle center on the x-axis. The Psi attribute defines the vertical position of the circle center on the y-axis. And the R attribute represents the radius of the circle, in other words, the size of the circle. In the first circle, the center is placed at position 200 on the x-axis and 150 on the y-axis, with a radius of 40 pixels. Then we create a second circle. This one is positioned further to the right at x position 350, while keeping the same vertical alignment and radius. Because both circles share the same y value, they appear perfectly aligned horizontally. This technique helps us place multiple SVG elements precisely using coordinates. Right now, these are just simple shapes with no effects. Section 2. Building the GUI filter. Now we create the filter. Inside the SVG, add. Next, we are adding a special section inside our SVG called DFS. The DFS element stands for definitions. It is used to store effects, gradients, filters, or reusable elements that will not appear directly on the screen. Think of this area as a storage section where we prepare visual effects before applying them to shapes. Inside the DFS tag, we create a filter element. The filter has an ID called GU. This ID works like a name, allowing us to apply this filter later to any SVG element using a reference. Right now, the filter is empty, so nothing changes visually yet. In the next step, we will add filter effects inside this section to create a GUI or liquid style animation. SVG filters work like a processing pipeline. Each step modifies the graphic. Step 1. Add blur. Now we are adding the first effect inside our SVG filter. Here we use feGaussianBlur, which is a filter primitive used to create a blur effect. The attribute in equals source graphic means the filter will take the original shape, whatever element we apply the filter to, as the input. Next, we have std deviation. This controls the strength of the blur. A higher value creates a stronger and softer blur, while a smaller value keeps the shape sharper. Here, the value 10 gives us a smooth, soft glow effect. Finally, the result attribute names the output of this step as blur. You can think of this like saving the blurred version of the graphic so we can use it in the next filter step. At this stage, we are preparing the base effect that will later help us create the GUI merging animation. Explanation: STD deviation controls blur strength. Higher values create stronger blending. Now the shapes look blurred. Step 2. Create the liquid effect. Add the color matrix. Next, we add another important filter step called feColorMatrix. This element allows us to manipulate the color and transparency of the graphic using a matrix calculation. In the attribute, we pass the result from the previous step, which was the blurred graphic, stored under the name blur. Next, we set the mode to matrix. This means we are applying a custom matrix transformation to the color channels of the graphic. Now let's look at the values section. These numbers form a 4-row matrix that controls how the red, green, blue, and alpha channels are processed. The first 3 rows keep the original colors unchanged. So the red, green, and blue channels stay the same. The real magic happens in the last row. Here we use the values 25 and -10 to dramatically increase the alpha contrast. This makes the blurred shapes become thicker and stronger. As a result, when 2 blurred shapes come close to each other, they visually merge together, creating the famous GUI effect. This is the key trick behind many modern SVG liquid animations. What this does: the blur merges shapes together, and the matrix increases alpha contrast, making the blur appear solid and liquid-like. Now apply the filter. Now we are adding a group element, written as the G tag. The purpose of the G element in SVG is to group multiple shapes together so that we can apply styles, transformations, or filters to all of them at once. Here, we apply a filter attribute to the group. The value URL, #GU, tells the SVG to use the filter we defined earlier with the ID GU. The word URL simply references that filter by its ID. This means that every element placed inside this group will automatically receive the GUI filter effect. So instead of applying the filter to each circle individually, we apply it once to the group, making the code cleaner and more efficient. In the next step, we will place our circles inside this group so they can merge together with the GUI animation effect. You'll notice the circles now look sticky. Section 3, Animating with GSAP. Let's bring the animation to life. Add the SAP CDN. Now we are adding an external JavaScript library called GSAP. GSAP stands for GreenSock Animation Platform, and it is one of the most powerful libraries for creating smooth and professional web animations. Here, we load the library using a script tag and a CDN link. CDN stands for Content Delivery Network. This means the library is hosted online, and our web page can load it directly from the internet without downloading the file manually. The link points to the GSAP version 3.12.2, which gives us access to advanced animation features. Once this script is loaded, we can use GSAP to animate SVG elements, such as moving shapes, scaling them, rotating them, or creating complex motion effects. In the next step, we will start using GSAP to animate our SVG elements and bring the GUI effect to life. Now animate the circles. Now we are writing the GSAP animation code that will move our circles. We start with sap.to. This function tells GSAP to animate an element from its current position to a new value. Inside the quotation marks, we write circle, which means the animation will target all circle elements inside our SVG. Next, we pass an object containing the animation properties. The first property is x, 100. This means the circles will move 100 pixels horizontally along the x-axis. Then we set duration, 2, which tells GSAP that the animation should take 2 seconds to complete. After that, we use repeat, -1. A value of -1 means the animation will repeat forever. Next, we add yo-yo, true. This makes the animation move forward and then reverse back, creating a smooth back-and-forth motion. Finally, we define the ease property, which controls the speed curve of the animation. Here we use power 1.in-out, which means the motion will start slowly, speed up in the middle, and then slow down again at the end. When this runs, the circles will continuously move left and right, and because we applied the Gooey filter earlier, they will merge together with a smooth liquid effect. As the circles move closer, the SVG filter automatically merges them into a liquid shape. This is the same technique used in modern UI loaders, interactive dashboards, creative web animations. Section 4, Final Result Breakdown. Let's quickly recap what we built. Created SVG shapes. Applied Gaussian blur. Used color matrix to strengthen alpha. Animated movement with GSAP. Result, a professional GUI liquid animation using pure SVG. No heavy libraries. No CSS hacks. Just powerful SVG filters. And that's it, you've just created a professional SVG GUI effect from scratch. If you found this tutorial helpful, thumbs up, like the video, it really helps the channel grow. Bell subscribe to @ThightMaster1 for more SVG, GSAP, and modern web development tutorials. Check the description for the full source code and the complete SVG animation series. I'm IT Master, and I'll see you in the next tutorial. Keep coding.